At the end of this module, you should be able to assign a row or column vector to a variable using multiple methods, convert a row vector to a column vector or vice versa, and assign a matrix to a variable. Let's look at a typical problem that will help you understand the learning objectives I just mentioned. An engineer is working on the design of a treadmill and needs to better understand the speed at which users start their workout. Distance and time data have been provided for 2 users using a treadmill at resistance level 7. To work with this data, the engineer needs to make it available in MATLAB. Let's start by looking at how to define an array. Arrays are a collection of data whose elements are arranged in rows and/or columns. This collection of data can be stored and manipulated. The 3 types of arrays you will come across most frequently are scalars, vectors, and matrices. A scalar is a one-element array. For example, if we assign the number 5 to a variable called a scalar, we have created a scalar variable that is a one-element array. A vector is a one-dimensional array and can either be a single row or a single column of elements. Here we create a variable called a vector and assign it to the numbers 5, 1, 0, and 10. We have created a variable now that is a row vector. The third kind of array is a matrix. This is a two-dimensional array. Its elements are arranged in multiple rows and columns. We can assign 6 values as shown here, laid out in 2 rows and 3 columns to the variable a matrix and create a two-dimensional array. Let's assign the distance values for user 1 to a row vector. What if I tried the variable named distance? Variable naming conventions apply, so distance is not a good variable name because MATLAB has a built-in function with this name. I can tell this from the error message I get when typing in this variable name. The error signifies that this is a built-in function in MATLAB. It would therefore be inappropriate to use as a variable name. I'm going to call my variable name user1 underscore dist underscore v1 because I'm going to assign the vector in a couple of different ways. When I assign the elements of a vector one by one, I use square brackets to indicate the start and end of the vector. In version 1, I use commas to separate the values. When I push enter, note the unsuppressed variable assignment displays to the screen showing the values in a single row without the square brackets or commas. The brackets and commas appear in the workspace window. I can assign the row vector using spaces instead of commas. Let's do this for version 2. Note what is displayed in the command window and in the workspace is the same as for version 1. I can use both commas and spaces, and in fact, I can use any amount of spacing I want. Let's make that version 3. See, no difference in the command window or the workspace. Alternatively, I could create a column vector. One way to create a column vector is to use semicolons rather than commas between the elements, as I am doing here. The semicolon is essentially saying put the next value onto the next row. When I push enter, note the way version 4 displays in the command window versus the workspace window. As with the row vector assignment, I can add spaces around the semicolons and it does not affect the end result. Look at version 5 of the variable that I have typed out here. If I want to only use spaces, I need a way to tell MATLAB I want a column vector rather than a row vector. A dot apostrophe at the end of the row vector assignment, called the transpose, will convert a row vector to a column vector. I can also use the built-in transpose function. When I want to assign a set of linearly spaced or equally spaced values to a vector, I have some other options. I can tell MATLAB the start value, the step, and the end value, with these values separated by colons, as I do in version 7 of the variable user1_dist. Note that MATLAB will not let the last value in the vector exceed the end value. So let's say I declared the end value to be 55 instead of 50. The last value of the last element in the vector will still be 50. I could also use the linspace function, where linspace translates to linearly spaced. When I type out this function in the command window, notice that I get suggestions on how to use the function. This function requires 3 input arguments: the start value, the end value, and the number of points desired between and including the start and end values. Linspace uses the start and end value provided, so you have to be precise. You can't say the end value is 55 and get the same result as you can with the assignment method that uses colon notation. I now have a variety of ways to create vectors for all the other parts of the dataset in the problem. Here I'm using a variety of ways that MATLAB allows me to save the data from the table in 4 different variables. Notice as they are being created, the variables are being stored in the workspace for use later. While I could store my dataset in 4 different variables, it might also be convenient to store the whole dataset to one variable. Let's go back to our dataset. The values in the table can be stored in a single variable by creating a matrix. Mathematically, the matrix would be written as shown. The matrix has 6 rows and 4 columns. To store this data in a 2-dimensional array or matrix in MATLAB, I use the same syntax I used to create row and column vectors. Let's call our variable name that will store the matrix user_data. I use brackets to designate the start and end of the matrix. I enter the elements row by row. I use space, commas, or both to indicate elements on the same row. And I use semicolons to designate a new row. I can hit enter at the end of any row after the semicolon. As long as I have not used the end bracket, MATLAB expects that I'm still adding elements to the array. Note that I do not have to push enter after each row to make a matrix. I just need a semicolon to tell MATLAB that the next entries are in a new row. However, I like to hit enter at the end of each row to make the data entry readable. Once I close the brackets and hit enter, the matrix is assigned to the variable. Note how it is displayed in the command window. In the workspace, the size of the matrix is displayed with the data type of the values contained in the matrix. Double is a numerical data type. I could use a matrix of commas and spaces with a row, and I could enter the whole matrix on one line. What I cannot do is hit enter in the middle of a row as I am after the 20 in the second row of the dataset. That produces an error because MATLAB expects matrices to be completely filled in rectangles of data. Here, MATLAB thinks you're trying to piece together 2 different matrices that are not compatible in size. We can summarize this module with 4 main points. Scalars, vectors, and matrices are all arrays. As we have seen, there are multiple ways to assign row and column vectors. A row vector can be converted to a column vector and vice versa. You can assign a matrix using the same syntax as row and column vectors.